Hello everyone, welcome back to your favorite YouTube channel, My Project Ideas, where we break down complex concepts into easy to digest pieces. I'm Simran, and today we are diving deep into the fascinating world of DSA, and today's topic that we are going to cover is check for prime. I hope you guys all know what are prime numbers, but if you do not, then no issues. We are going to cover this topic from scratch. So let's move further. So, what are prime numbers? A prime number is basically a natural number which is greater than 1 and it is divisible by 1 and the number itself. So, if you know the number of prime numbers, so it starts from basically 2. So, it's 2, 3, 5, 7, 11, 13, and it continues further. So, again, a definition of prime number can be a positive integer which is greater than 1 and has two factors, that is 1 and the number itself. There are multiple prime numbers like 2, 3, 5, 7, which I already told you, and it is highlighted here also, as you can see here in the box here. So 1, a number 1, it can be considered neither as prime nor as composite. These are some of the facts, guys. Just keep in mind because these are basic things. Then, what are the interesting facts about prime numbers? Except for 2, which is the smallest prime number, that is the even prime number, all other prime numbers are your odd numbers. So 2 is the smallest prime number and it is the only one even prime number. And every prime number can be represented in the form of 6n plus 1 or 6n minus 1, except what? 2 and 3. And 2 and 3 are the only two consecutive natural numbers that are prime. When you move forward, like in the number system, you won't find any other two consecutive natural numbers that are prime. And we have certain theorems here. It's not important. Just for your information, I have written down them. If you want to look at it, this PPT will be given to you. You can have a look. That is for your knowledge only. No one's gonna ask you about this. It's not important. Okay. Next. What are the properties of prime number, guys? We have already discussed. Except to all the other prime numbers are odd. Every number greater than 1 can be divided by at least one prime number. Every even positive integer greater than 2 can be presented or expressed as the sum of two primes. Important. Two prime numbers are always co-prime to each other. What is co-prime? Co-prime means they have no other common factor except 1. Suppose 2 and 3. So 2 and 3, if you just jot down the prime factorization of 2 and prime factorization of 3, you get 1 into 2 and there you get 1 into 3. So what is common? 1. And each composite number can be factored into prime factors and individually these are unique in nature. Next. So, co-prime numbers I have already discussed that suppose 13 and 15 are co-primes. Not suppose, actually 13 and 15 are co-primes. So, what are the factors of 13? 1 and 13. For 15, we have 1, 3 and 5. So just look at 1 and 13 and in the next jot you have 1, 3 and 5. So, what is common here? 1 and 1. So, from 13 you get 1, from 15 you get 2. So, 1 is their common factor. Therefore, they are the co-prime numbers. Now, how do we check whether a number is prime or not? We know the algorithm. We can say it, we can speak it, we can make someone explain, or we can explain it to someone else. We can make someone understand what is prime, how to find out prime. But are we able to code, guys? You know the algorithm right now. Just take some time, pause this video for a second, and try writing the code by your own. So I hope you guys have written the code. So I have already written the approach here. So this is the naive approach. So you have to iterate from 2 to square root of n. And for every number you have to check if it divides and why up to square root of n, because it shortens the iteration. And it is same as going till n. Okay. So if a number is divisible by n, it will obviously be divisible by square root of n. Okay. So this code which we are gonna write, it will have a time complexity of big O of square root of n and auxiliary space of big O of 1. Got it? So I hope you guys have already written the code. Now it's time for us to write the code together. Some people who have not written the code, please look at it and try to understand. And people who have already written the code, just check whether you have written it correctly or not. So let's import math first because we are going to use the square root function. Then let's write the function, that is def is prime. Then let's put the parameter as n. Now let's put if. These are the corner cases, guys. Okay, less than equal to 1. Then we are going to return. Okay, we completed. There's an error. Okay, we completed this. Now let's move to the next section. That is, we are going to check from 2 to the square root of n, which I told you already. So let's write for I in iteration, right? For I in range. So it's a for loop. What's the range? 2 to square root of n. So let me write int math dot sqrt square root of n, and I have to add here. Okay, because I'm starting from 2. Next, if n mod I is double equal to 0, then what we are going to do? We are going to return false because we got a, like, it is divisible by some number. So it's not uh, a prime number because a prime number is divisible by 1 and the number itself. Okay, or else let's return. Now let's write the driver code. The driver code will be if is prime. Let's put the number 11. We already know the answer whether it is prime or not. So it's prime. So let's print here true, or else we are gonna print what? False. Okay. So we have already written the code. Simple, easy. Let's run it. So it says true. So 11 is the prime number. Got it? Now let's move to the PPT again. Let's begin animation. Here we are. So now, okay, we already got to know that, yeah, how to check it is in a naive approach. But in the naive approach, guys, if the size of the given number is too large, then the square root also will be very large. So now what we are going to do is we are going to have a trick. So to deal with the large size input, we have to deal with fewer numbers like 1, 2, 3 and numbers which are divisible by 2 and 3 in separate case. So what are we going to do is we are taking the 2 and 3 cases out and we will iterate the loop from 5 to square root of n. Okay. And we are checking whether it is divided by n or not, or whether it divides n or not. Because see, if a number is quite large, then its square root also becomes quite large. And you know that the 2 and 3 cases, if you put it separately, you can iterate the loop from 5 to square root of n, which will reduce your test cases. Okay, so I think it's a bit difficult just to explain. So what we are going to do is, let's begin coding. So you will get to know what I mean. So let's move to VS Code again. Let's create a new file, that is prime. Check for prime. Check for prime and efficient. Dot Python. Okay, let's close this. Let's begin our coding. Again, some people who already know how to write the code, who understood the algorithm, you can go forward, you can pause this video and you can begin coding. And others, just code with me, follow me, and just be with me. Let's write it import math. Then let's write the function prime. We put n here, parameter. Then we have to check if n is equal to 1 or n is equal to 0. If n is equal to 1, we'll have another case. If n equal to 0, we'll have another case. So let's see if n is less than equal to 1, what are we gonna do? Return false, because we can't say whether it's prime or not prime. Then let's check for n is equal to 2 or n is equal to 3. So if n is double equal to 2, because we know that these are prime, or n is double equal to 3, then we're gonna return true because we know that they are prime. So we're treating this in a separate case because these two are consecutive primes, right? Then what we are gonna do is important. So if a number is divisible by 2 or it is divisible by 3, then it's not a prime because it has another factor that is 2 and 3, 2 or 3. So we are gonna check if n is divisible by 2 or 3. So let's write the code n mod 2. So guys, it's very simple. If you just break down the code into subsegments and you try to code, just try deciding, just try like you should know how to write, because writing the code is simple guys. Figuring out the algorithm becomes difficult in DSA. Then return. If you know the algorithm, everybody can code. Then what are we going to do? We are going to check from 5 to square root of n. So let's then initialize the variable I is equal to 5. Then while condition I is less than equal to math dot square root of n, qrt of n. Now again we will check whether it is divisible or not. If n mod I is double equal to 0 or n mod I plus 2 is double equal to 0, check it, return. Okay. Then you have to increment the value of I, because this is a while loop, not a for loop. So because in for loop, in the conditional part only you increment the values, but here you have to increment the value afterwards. Then return true. I guess you understood up to this. Now nothing much, just write the driver code. Your logic is done. Next, let's check the indentation. Yeah. If is prime 11, print true, else print false. Okay, let's save it. Let's run it. Got the answer. Okay. So guys, I hope this code was quite understandable to you. I hope you enjoyed it, and like just keep practicing. And I hope you guys understood what is written in the code. You guys understood the complete prime factorization, how to find out whether the number is prime or not. So now it's time to wrap on today's video, and I hope this was really helpful for you. So let's come back again for another interesting video. Still then, stay tuned, keep coding and keep learning.